Welcome back to another episode of Math Team Productions. Today we are going to be looking at Pythagorean Theorem and trigonometry, but first we are going to look at two real-world application problems that covered the material from last week, which was midpoint and distance. So whenever you're taking the ACT, remember you have 60 questions to answer, and you have to answer them in 60 minutes. That is exactly 1 minute per question. So time is not on your side on this test. So if you have a problem that's very wordy like this, for me, I would first skip this and go to other problems that may not be as wordy, maybe will be more self-explanatory, and get those done first, and then come back if I have any extra time and get these other wordy problems done. So let's pretend we went through all the problems that we know and we have some extra time left, so let's get these two problems done. So we're going to first read it from the get-go. The math class is mapped on a coordinate grid with the origin being at the center of the whiteboard. Ms. Harmon's seat is located at the point -4, and Coach Stecker's desk is located at -2, What would be the coordinates of the desk in between Ms. Harmon and Coach Stecker? It's not as self-explanatory. It's not telling you find the midpoint, find the distance. It's just saying what would be the coordinates of the desk in between Ms. Harmon and Coach Stecker. So that is where you have to figure out what you are trying to find. They did give you a hint though. They said in between the two desks. So in between means in the middle, aka midpoint. So we're finding midpoint here. And our two endpoints are my seat and Coach Stecker's seat. Now, as a reminder, the midpoint formula is just adding the two x coordinates and dividing by 2, and adding the two y coordinates and also dividing by 2. So I like to write down the information that's given to me because it's kind of hard to figure everything out when everything's all in a giant paragraph. So for Ms. Harmon, that point is -4, and for Ms. Stecker, that point is -2, Now you have to label the point x1, y1 and x2, y2. It does not matter which one you pick, okay? So this is x1, y1, x2, y2. Now I have numbers to variables. So I'm just going to simply plug it into the formula. So -4, which is x1, plus -2, which is x2, divided by 2. 7 plus 5, which is y1 and y2, all divided by 2. All right, I'm going to first figure out the x coordinate. Now remember, the ACT math test is a multiple choice test. So let's first figure out the x coordinate. So this is -6/2, which that simplifies to -3. So we already know the x coordinate of my midpoint is -3. So I would go through my answer choices and get rid of any answer choice that does not have -3 as the x coordinate. Hopefully it'll narrow it down to just one answer and then you just answer it and move on. Or you might have 1 to 2 answer choices that do have -3 as the x coordinate. So in that case, you will have to figure out the y coordinate. So 7 plus 5 is 12. 12 divided by 2 is 6. So I'm looking for -3, 6. And that is your answer. On to the next problem. We have Coach Lee throwing a football, and he's throwing this football from a position that is 10 yards from the goal line and 15 yards from the sideline. His receiver, Mr. Daniel, catches it at a position that is 50 yards from the same goal line and 5 yards from the same sideline. Find the distance of the throw. So usually that last sentence is what they want you to do, which in this case is finding the distance of this throw. So the only thing that I know about distance is the distance formula. So I'm going to jot that down real quick. Feel free to jot that down with me. So all of this is inside a square root. Now, I see x2, x1, y1, y2, all of these letters, but it's not very clear to me which number goes to which. So I'm going to just relook at the problem again. And I noticed that there's two things that's happening in both situations with Coach Lee and Mr. Daniel, and that's the positions that they're at. Now this first number is yards from the goal line, and this second number is yards from the sideline. And if you notice that, Mr. Daniel also has certain number of yards from the same goal line and from the same sideline. So I could probably create some points from this. I like to write down what X and Y mean in regards to the real world problem. So X for me is going to be the number of yards from the goal line, and Y is going to be the number of yards from the sideline. Okay. Now, I have two people here. I have Coach Lee and I have Coach Daniel. So I'm going to make their positions coordinates. So X coordinate is the yards from the goal line, and for Coach Lee that's 10, and for Coach Daniel that's 50. And for my Y coordinate, that's the number of yards from the sideline. For Coach Lee, that is 15, and for Coach Daniel, that is 5. Okay, now I have points. Now I can do something with this and putting it into my formula. So like I said before, it doesn't matter which one you pick as X1, Y1 and X2, Y2. For this example, I'm going to choose Coach Lee as X1, Y1 and Coach Daniel as X2, Y2. And now I'm going to plug it into my formula. Now, at this point, you could plug all of this into your calculator. For me, I like to write it out so I know exactly what I need to put into my calculator. So X2 is 50 minus X1 is 10 plus Y2, which is 5, minus Y1, which is 15, and that's being squared. All right, I'm going to save us some time here. I'm going to plug it into my calculator. So I have the square root. Square root, you press second, the blue button, and X squared to get the square root. And I'm going to just type it in as I see it. So parentheses 50 minus 10 squared, and press enter. Okay. On your paper, it says round to the nearest yard. If it tells you to round to the nearest something, you're probably going to get a decimal. And in this case, yes, I do. I get 41.23. And so I'm going to approximately 41.2 yards. Okay, it says round to the nearest yard. So yard means one's place. So one's place in this 41 is the 1. Now you round, you look behind the 1, that's a 2. It is not 5 or above, so it stays at 41. So that distance was approximately 41 yards. Now on to the lesson of the day. We have Coach Lee first talking to you guys about the Pythagorean Theorem.
I got it. The lengths of the two legs of right triangle ABC shown below are given in inches. The midpoint of AB is how many inches? So it's got a couple things going on here. First thing is we're going to be using Pythagorean's theorem because we know two legs. We want to know the hypotenuse of the right triangle. So Pythagorean's theorem is a squared plus b squared equals c squared. You can ask your parents what Pythagorean's theorem is. Usually they know a squared plus b squared equals c squared, but do they know how to use it? You need to figure that out, all right? So we got legs here, A and B. The hypotenuse is always C. 32 squared plus 24 squared is equal to C squared. We're looking for the value for C. Once you put this in, it comes out to be 1,600, I think. Take the square root of that. Square root of both sides. That's 40. So the hypotenuse is 40. Notice on the ACT, they've got 40 as an answer choice. That's not what we're looking for. Let's always make sure we read the question. The midpoint of the line AB is how many inches? So the midpoint is in the middle, so that's going to be half the distance of the hypotenuse, which is B20. Thank you. Have a great day.
So today on Math Team Productions, we are looking at a trigonometry problem. I know that when I read this last sentence, it says, what is the value of tangent of theta? So think back to your geometry class. You were probably told at some time, SOHCAHTOA, where your S stands for your sine function, your C stands for your cosine function, and your T is your tangent function. Now, because we're looking for tangent of theta, this is a theta, it's not a zero. This is just represents some angle that we do not know. It's right here in this picture. So
some of you have forgotten or have no idea what Coach Wilson is talking about when it comes to SOHCAHTOA. So I'm just going to give you a little crash course on SOHCAHTOA. SOHCAHTOA is an acronym, and it represents sine, cosine, and tangent functions of theta. Theta is, like Coach Wilson said, not zero. It's just a symbol. It's a Greek letter, to be exact, that just represents the unknown angle that we are trying to find. Theta is a part of a triangle, and there's three parts to a triangle. The first one is the hypotenuse, and then we have the opposite side. It's directly opposite of theta, and then we have the adjacent side, which is kind of like next to it. So for sine of theta is actually the opposite side, whatever length that is, divided by the hypotenuse, whatever length that is. For cosine, we have the adjacent side, whatever length that is, divided by the hypotenuse. And tangent is the opposite divided by the adjacent. So on the question that he is going to cover, he's finding tangent of theta. So we are only looking at this third part of SOHCAHTOA. Thank you.
in this picture, well, where's my triangle at? If I draw a line right here, I have my right triangle. Then I need to identify the opposite side is opposite of the angle given. So this is my opposite side. And then my adjacent side is the side that is in between the angle. It's beside the angle and beside the right angle. So this is my adjacent side. Now that I have these labeled, how do I know these distances? Well, 10 represents the x-coordinate. So it's from left to right. So this distance will be 10. 4 represents our y-coordinates, so it is 4 units up. So this distance is 4. So then we get opposite, which comes first, so we get 4 over 10. Now, you see that that's not a choice. We can simplify that to 2 over 5. Our correct answer is D. Thank you.